Hey guys, here's just a quick little video to help you with graphing a derivative based on an original function. So the main things to look for here, really, you're not going to be able to get the exact values, except really when the slope is 0. But just try to get the sort of relative nature of what's happening. Is the slope positive? Is it negative? Is it really, really positive? Is it really, really negative? Is it gradually getting to 0? All those questions can help you sort of sketch what the graph is going to look like. So I'll do just number 7 here real quick as a quick example, and hopefully that'll kind of help you through any of the ones you have to do. So I'll just, same little graph. The first thing I look for personally, I really just look for where the slope is 0. That tells me exactly where this graph may cross the axis. And in this case it looks like pretty much right at 0. At x equals 0, the slope is 0. So if the slope is 0, and this is a graph of the slope, right, the derivative, well then the value of that graph is going to be 0 when x is 0. So when x is 0 for the original, the slope is 0. So I'm basically plotting the point 0, 0 for my derivative. Okay, because essentially what I'm saying is f prime of 0 is 0. That's basically why I'm plotting this point. Okay, so if this is a graph of f prime, then 0, 0 is on that graph because the slope of the original at 0 is 0. Alright, now I look for, okay, basically how does this thing start? Well, this slope of the original is definitely positive. In fact, I would say it's wicked positive, super positive, ultra positive, uber positive, whatever you want to call it, it's darn positive. So I'm not going to start my graph here. Right? That's just a little positive. Now, there's no values, there's no scale, so you might argue, oh, well, what if I wanted this to be like 10,000? Well, let's just try to make it reasonable, okay? So this is super positive, and it's getting less and less positive right about here. I'd say it's still pretty high until, maybe this first little notch here to the left of 0. Again, there's no values here. So if you want to call this -1, I'd say about -0.5, it seems to start leveling out. Okay, so I'm going to start really, really high, and then finally approaching the 0 here, right about there. Okay, so I have a really high slope, high value I should say, at this moment at x equals, again I'm just going to call this -1 just for argument's sake, because at x equals -1 I have a super positive slope. Okay, now one of the confusing things that sometimes mixes people up is you look at this graph and you say, oh, y value is negative, so I need to start down here. But you're not copying the graph, you're looking at the slope. So the slope here is positive, so f prime, here I'll even write it like this, equals wicked positive. I have no idea what that really is value-wise, and nor am I saying that this is really -1. I'm just saying the slope is really, really positive to the left of 0. So the derivative at a little bit left of 0 is wicked positive. So that's why I started way up here at what I would quasi-call -1. Alright, so what's happening after that? So I get to 0, so I'm super positive, less positive, that's why I'm coming down, and then eventually 0. Then it's a little bit negative. And it's a little bit negative for a little while, right? I'd say it's a little steep here, maybe it's steepest here, and then it seems to start gradually, coming down. So it definitely crosses through, but then it starts to level out again. It doesn't look like it gets all the way to a 0 slope, but it definitely looks like it wants to come back up. So I can't just go, straight down, right? That would imply that this is going straight down, implying a very negative slope. But it's just negative for a little while. It's negative to a decent amount, maybe about here, negative slope, and then it starts to level out. It's less negative and less negative. And when I say less negative, I'm talking about slope again. So it's less negative slope, less negative slope, less negative slope until it's almost 0 slope. So I think I'm coming back up to here. Now, I don't know for sure how close it gets, right? I can't really tell. All I know is if I had to predict what this was going to do next, it looks like it wants to do one of these. I have no idea. It could easily turn back down. But in my head, I'm like, okay, this looks like it's leveling off, so then my slope is leveling off until it might actually cross through. This could be a little steeper. I'm not sure. And I haven't drawn it perfectly, but I think if I looked at this derivative, if I didn't look at the original, and I just looked at the derivative, I could basically tell you what the original is doing. Okay, really positive slope, pretty steep positive slope all the way till here, right? So it's going, the original function is going up, 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 right, until it balances out. It's basically, I mean, obviously we know what it looks like, but I'm just saying, like, really positive slope till it balances out, It crosses over, so now I go from positive slope to negative slope. So I must be doing one of these, right? Like a parabola opening down. And then it seems to be telling me that it's not that negative of a slope, and in fact it's actually getting less negative, almost to 0. So, oh, great. That's helpful. Oh, thanks. Thanks, Starburst. Yeah, okay. Thanks. Appreciate that. It's very helpful. All right. Where did I leave off? So I can tell that my slope, my derivative has a negative value, means my original has a negative slope. Right? They go hand in hand. This is describing the slope of this. This is the original. This is the derivative. Okay? This is odd, so it should be in the back. Let's just take a quick look. I'm kind of curious how close I got. Let's see. What is this? 4.2. Or 3.2, I mean. 3.2. All right, let's see. Am I close? Number 7 is up here. What did I have? Well, that's not too bad. That's not too bad. Right? You see it? So again, look at theirs. Super positive value, implying super positive slope of the original, until eventually 0 slope. Right? Then it's a negative slope, but it comes back. This is the key right here. Right? I should have saved that page. This is the key right here. Here, watch this. 143, I think it was, yeah. Here we go. This is the key right here. The fact that this is flattening out tells me, or told me, I should say, that this is happening here. It's so easy to want to just like go down, right? You start from positive slope, you go to negative slope, you just go straight down. But the way it's actually going is very descriptive. Like it's going in a certain way. It's going steep, shallow, flat. Steep-ish, right? I mean, it's shallow, sorry. Shallow to its steepest moment. It's not steep, but it's steepest here down. Then flat. Okay? And that's why, I'm guessing that's why the derivative never really gets that low, right? Because there never really is that much negative slope. There's no wicked negative slope. There's wicked positive slope here, but this is not wicked negative. And look at the original. It's wicked positive slope here, and medium at best slope. Right? Negative, medium, negative slope, and then basically very little negative slope. And that's what you got to do. That's how you got to sort of interpret it. Okay? Hopefully that helps. Do your goodest, and let me know if you have any more questions. Okay? See ya.